I'm Annie Haas, and I'm the program co-lead with Incubate Energy, and would like to introduce to you today Team Switch Source. And we're going to dive right in with some questions for the team about this project. Charlie Murray from Switch Source, would you mind introducing yourself and talk a little bit about your technology and why you wanted to join this program?
Absolutely. Hi, I'm Charlie Murray. I'm the president and founder of Switch Source. Here at Switch Source, we make power electronics equipment for distribution utilities. And right now we're developing a new technology called the Phase EQ for balancing power on three-phase circuits. And what this really means is when we look at the way that utilities deliver power to customers, they typically use three phases. If you look at that power pole, there's typically three wires across the top of it. And they use one of those wires in what's known as a lateral to feed a group of customers. So what Switch Source developed was a device that can actively balance the loading on these three-phase circuits from phase to phase and help mitigate some of the power quality and efficiency issues that arise as a result of phase imbalance. As we were working on developing this technology, we saw this great opportunity to work with Incubate Energy, work with the utility to perform a benefits cost analysis for this technology. So we're really relying on EPRI's expertise in power system simulations, as well as their expertise in benefits cost analysis, and then also having the help of a utility at the table to guide us in that work.
Thank you so much. Could you first introduce yourself, but also talk a little bit about the project and the importance of phase imbalance on distribution feeders?
Sure. Thank you, Annie. So my name is Jeremiah DeBoover. I'm with the Power Delivery and Utilization Group and at EPRI, and I'm focused on distribution system modeling and simulation. And so for like Charlie mentioned, phase imbalance can become pretty severe on some feeders. And what that causes is that it can create voltage imbalance on the feeder as well as current imbalance on the feeder. And so one of the phase can have hit the limit of operation where a utility would need to address that issue before adding more load or having more customers. And this issue can be exacerbated by DER. So a residential PV can make that problem even more significant, where traditional solutions cannot be used to address that issue.
All right, next up, Cody Davis from Ameren. Cody, would you mind introducing yourself and talk about what solutions are out there for phase imbalance and how is Ameren looking at it?
Yeah, thanks, Annie. So my name's Cody Davis. I work in our DER integration group as a power systems engineer. Phase balancing on the utility side, typically we are most commonly physically moving taps from being connected from one phase to another phase to try to balance it. Typically we're looking at one specific moment in time. So there's some issues that come up when that imbalance varies significantly over time. We also do some projects to mitigate some of the symptoms of phase imbalance, like overloads or voltage imbalance, by adding voltage regulators or replacing overloaded equipment. So our approach with this device was really to find high impact areas where phase balancing is causing problems and evaluate the phase EQ and how it relates and compares to those traditional solutions.
Awesome, thank you. Jeremiah, back to you. Could you talk a little bit about what you found in terms of the techno-economic benefits of this device?
Sure, thanks, Annie. So as EPRI, we wanted to have a techno-economic evaluation, so a cost-benefit analysis of the device and have an impartial view on the benefit that it would provide to the grid. So the first step in our cost-benefit analysis was to look at all the technical benefits that the device can provide in terms of balancing the phase voltage, balancing the phase current, helping with integration of DER, reducing neutral current, or any energy efficiency improvement that it would provide. We looked at all these technical benefits and to see if any of them could be monetized and compare them to how traditional mitigation measures could be used to understand what is the economic or the business case for this device. There's some ideal feeders that we have identified in this study was a feeder that is a repeated offender of phase imbalance that needs to be addressed every year, or feeders with severe phase imbalance that cannot be addressed with traditional mitigation measures could benefit from having the phase EQ as a device, as a mitigation solution. Additionally, we also found that feeders with high penetration of rooftop solar could be problematic feeders for the utility, where the phase EQ could provide that solution for them.
So Cody, how has this project helped you guys, and where do you see it going next?
I think the project's been really helpful for us to see both the method and sort of get an estimate of the magnitude of the benefits of the phase EQ and kind of capture the analysis method for how we can look at where to deploy this thing. I think it adds a new tool to our toolbox as a new solution to an old problem. And I think that's been really exciting to see and develop, especially in the abbreviated time frame here. We've learned a lot and got a lot of work done in not a lot of time. So it's been very helpful for us.
So people can reach out to me directly. Feel free to just send me an email. We're happy to provide information, give you a little bit more technical background and specification of the equipment. We also have the same tools that we put into the hands of EPRI that we can give to distribution planners so that they can start playing with our devices in their modeling and simulation packages, getting a sense of how the phase EQ can help them on their systems.